14 works for me. All right, 14. Inverse sine. Probably the first thing I'm going to do is inverse sine has to come from 1 or 4. So I know my answer is going to be in 1 or 4. If it further helps, you can think, well, sine is positive in the first and negative in the fourth. And so this one's negative, so it's got to be in the fourth quadrant. So I've narrowed it down already. Answer's got to be in the fourth quadrant. Okay, now where is the sine 1/2? This is where driving forward well helps you drive backwards. The sine is equal to 1/2. So let's see, 1/2 is the short side. So I'd want y to be the short length. Maybe this is a way to do it. That makes a shallow angle. So that's pi over 6. Well, it's negative because we're going down. So negative pi over 6. Is that better, worse?
The light bulb went off, but I understand.
Okay, I hope that's what that was. I wasn't sure if that was the light bulb going off or the... I'm still lost, look.
I didn't realize that, yeah.
That's okay. That's why we're spending 2 days on it, to give the more light bulbs a chance to go off. All right, what else? Let's do another one. Sine's kind of the easier one. How about number 7, cotangent? Yeah. Yes, we can do number 7. Cotangent. So cotangent is friends with cosine when it comes to where we can look for our answer. First and second. Cotangent's positive in the first, negative in the second. This one's positive, so it's got to come from the first quadrant. In fact, anything that's positive is going to come from the first quadrant, so I could have shortcutted all that. I don't really think about cotangents. I'd rather think about tangents. So I would flip that over so that I can think about tangents. The tangent 3 trick still works, but it has to be in simplified form, so I need to fix that square root thing. So I want inverse tangent of root 3 over 3. Well, there's 2 3's, and 2 3's make a 6. So I know it's over 6. I already said it's in the first quadrant. There's only one angle in the first quadrant that's also over 6. Pi over 6. So the tangent 3 trick really, really helps when you're going backwards with these inverse tangents and cotangents. Otherwise, you're trying to figure out who's y and who's x. And it's just a lot easier if you know the tangent 3 trick. 2 3's make a 6. So I flipped cotangent into tangent. Got it? Okay. The danger is if you stop there and say, oh, there's 1 3, so it's over 3. Like, well, no, I'm not finished cleaning that up yet. Once you clean it up, then there's 2 3's. What else? Secant, cosecant?
10.
Which one?
10.
10, secant. Okay, secant, you know what? Let's skip to it's positive, so it's got to be coming from the first quadrant. I don't think about secant, I'd rather think about cosine. So let's flip it over. That doesn't look good, right? Like that doesn't look like a unit circle value, but I need to fix it. So 3 root 3 over 2 times 3. 3's cancel, and I get root 3 over 2. That does look like a unit circle value. So if the cosine is root 3 over 2, and cosine is the x-coordinate, this is the long side, so I want the triangle to have a longer x. Well, that's got to be pi over 6. What was that? Oh, just because the 3 that we worked were pi over 6?
No, even the first one.
First one's pi over 6. Second one can't be pi over 6 because it's the inverse sine of a different value. So that one would be pi over 3. Yep. All right, feel better about these now? Better enough to move on, or you want more examples?
One more like a 1.
Okay? Like 19 or 22?
Yeah.
Wait, if it's like negative of another one, your final answer, is it just negative of the answer?
Not necessarily. That's a really good question. See if I can repeat it the way Andrew said it. If it's negative of another one, is the answer just negative of what we got? Something like that. Yeah, comparing number 13 and number 2. So sine has to come from here. First or fourth. Negative means it's got to be down here. So it's negative pi over 3. Okay, so your question is, looking at number 13 and number 2, like we changed the answer from positive to negative, or the ratio, and that flipped the angle from positive to negative. That works for sine and for tangent, but it doesn't work for cosine. In fact, for cosine, you'll never have a negative answer anyway, because all your answers are from quadrant 1 and 2. So it's a really good question and a really good observation that's true for some. Like number 2 and number 13 fit that. But if we found some cosine ones that matched, it wouldn't be true. I don't know if there's any on there, but
Well, kind of. Number 15 and number 4.
yeah, 15 and 4. 15 and 4. Cosine, inverse cosine of 1 is 0. And then number 15, the inverse cosine of negative 1, definitely not negative 0. Cosine is negative 1 over there at pi. So good question, good observation. True for sine and tangent, but not true for the others. All right, let's move on to today.